In this lecture, I'm going to explain about how to apply Newton's laws of motion for problem solving. So I'm gonna to explain the very important formulas from the Newton's laws of motion and discuss how we can apply solving problems. Okay, so getting started, you know it, but I'm gonna to briefly review the Newton's laws. What is the first law of motion? According to first law of motion, if external force applied in the system when an object is absent, then either it remains at its state of rest or it will continue its motion in one direction with constant velocity. That is the first law of motion. In mathematics, we can say this one, right? Summation F, that is sum of the all forces that we also call the net force on a body is equal to 0. This is said to be equilibrium condition. So let me write down here equilibrium condition. Okay, so this is the first law. So second law tells you net force acting on a body is equal to ma, where m is the mass of an object, mass of a body, and a is the acceleration in the direction of net force. Remember that acceleration will always be in the direction of the net force. Okay, this is the second law. And the third law is, in every action there is equal opposite and equal reaction. In general, while applying Newton's law, we have to use Newton's first law and second law. And sometimes, if there are forces in pair, we can use Newton's third law to identify the action reaction forces in pair. Okay, we simply use it. There is almost no calculation for Newton's third law. Newton's first and second laws are very important laws that we can apply to solve the problems related to the force acceleration. Okay, so let me start from the first law. According to first law, net force, which is denoted by this first equation right here, summation F is equal to 0. That is the condition for equilibrium. While solving problems, you have to split the components of the forces into x and y component and equal separately to 0. That means you are splitting vector f, which is force, into its x component and y component. Look at here, first equation is the x component of the force, net force, and second equation here is the y component of the force. Get the equations along the x-axis and y-axis. If according to the equation, if we could apply Newton's first law, we could only apply Newton's first law if a body is in equilibrium condition. Okay, if it is at rest or at constant velocity without changing direction, because if velocity is constant but direction is changing all the time, that doesn't mean particle is at equilibrium condition, right? To have equilibrium, acceleration should not be there, velocity should be constant, or body should be at rest condition, or direction should not change, right? These are the criteria to have equilibrium condition. Okay, so once you obtain equations along the x-axis, that is the equations of forces along the x-axis and the y-axis, equate those equations equal to 0. That gives you the equations so that you can calculate, you can determine the unknown variable, you can solve for the target variable. Okay, so that is the first thing, applying Newton's first law of motion. If there is acceleration, if acceleration is present, you can't apply Newton's first law, right? In that case, you need to apply Newton's second law of motions. So why Newton's second law of motion? Look at here, acceleration is here in the Newton's second law of motion. So summation F, which is the net force, is not equal to 0. In that case, acceleration will be there, and we can calculate the acceleration or whatever the unknown variables in the problem. Okay, as we did in Newton's first law of motion, we can split into components. This is the uh, pull force, the net force, right? And we can split this force into its component. How much is the force along x-axis, which is summation Fx equal to max. Ax is the x acceleration, Fx is the force along x-axis, and summation Fy equal to may, which is y acceleration, the acceleration of the particle of a body along y-axis. Okay, so once you are able to split these forces into x and y component, then you can sum all the forces along the x-axis and along y-axis and equal to may or max. Okay, based on which axis you are choosing at the particular time. Okay, uh, after getting these equations, few things are known in an equation, and there are some variables, some unknown quantities, some target variables that we have to calculate the values. Okay, so this is the way how to use Newton's first law and the second law in the equations, so when solving problems. Okay, uh, friction is the other thing that comes into play when we are dealing with forces or Newton's laws of motion. That's why I have included the formulas related to the friction. And the frictional force is closely related to the normal force. If you are not familiar with normal force, simply it is when you put some object here, normal force will be acted by the surface on which you kept an object, and it will always be normal to the surface, this surface. That's why this is the perpendicular force denoted by small n or capital N or Fn. That is the normal force. In general, denote it by small n. And friction force, another thing is friction force is always the perpendicular to this normal force and parallel to the surface on which you put an object. And suppose that force is acting in this direction, and frictional force will be acting here, right? The frictional force could be static frictional force or kinetic frictional force. If it is static, it can be denoted by Fs, or if it is kinetic frictional force, then Fk, right? So these are the symbols. And remember always, F frictional force is directly proportional to the normal force. If you increase the normal force, it means if normal force is more, frictional force will be more. If normal force is less, the frictional force will be less. Right here, which is the mu k, is the coefficient of friction, which is the ratio of frictional force to the normal force. Okay, so this is the kinetic frictional force. Kinetic frictional force means when for object is in motion, that we call kinetic frictional force. When object is at static condition and there is a friction, that we call static friction, and it is given by this formula: Fs less than equal to Fsn. Why less than? Until it attain the maximum static friction. That is the point right before a body starts to move. That is the maximum static friction, right? Before that, the friction, the force is less than that maximum. That's why less than sign is here. Fs, that is the static frictional force, is less than mu s, coefficient of static friction, multiplied by n, which is normal force. Okay, so these are the formulas for kinetic friction, static friction, and maximum static frictions. Remember always, the static friction is always more than the kinetic friction. It means when objects are in motion, the frictional force acting on between the objects will be less in comparison to the static condition. Okay, now let me discuss little bit about the radial acceleration, ARAT. This is actually the acceleration towards the center of the circle, in which a particle is moving in the circle with constant velocity. While writing this equation, we consider velocity is constant, v equal to k. Okay, a rad, because velocity is acting towards the center of the circle. You know, this is an object which is moving in the circle like this, and the radius of this circle is r. This is the center C. So if constant velocity of this particle, this object is v, and the radius is r, the radial acceleration, which is acting towards center, right? That's why we call it radial acceleration. When particle is moving with constant velocity, there is only one component of acceleration, which is radial acceleration. In this case, the parallel component is absent, right? So a radial is given by velocity squared divided by r, which is the radius. Okay, we can express this into other form, because velocity is simply distance divided by time. If for the circle, let us say time, that we call period, is to complete one circle, it takes time t, capital T. So I can write down capital T, right? What is the distance of the circle? Simply twice by r. And right here, radius of this circle, if radius is capital R, I can write it down, and divided by t. That is the velocity. If we square this one, I can square on the right hand side as well, and finally I will get 4 pi square r square divided by t square, right? Divided by t square. So if you insert this value in this equation, what will you get? You will get this equation, right? Let me write it down and get it. Simply put that equation, a rad is equal to this is 4 pi r square divided by 1 r is already there, t square here, r will be cancelled, and what will you get is the 4 pi r square divided by t square. Okay, sometimes probably velocity is given in the problem and radius is known, then you can calculate the radial acceleration by using this formula. Some other time we know about the radius and we know about the time period, but we don't know the velocity. In that case, to calculate the radial acceleration, you can use this formula. Okay, depending on the situation, you can use different formula.